cos theta value, so we can find the sine theta value. So sine square theta is equals to 1 minus cos square. So it's a 2 square over 27 square. Use the calculator and see what you get. 1 minus bracket 2 square, which is a 4 divided by 27 square, done, and equals to, I end up getting 725 by 729, please. 725 by 729, that's a cos sine square theta's value. Let's find square root. We need sine theta, please. That's a 5. Well, theta value we got as 5 root 29 over 27. Right, 5 root 29 over 27. Once you reach that stage, we know the theta value, and area of the triangle we know, half AB sine C. A is that, modulus of A is nothing but the length of the line, so it's a 9 and 3. So area is equals to, so half AB sine C. Half is a half, times A is a 9, times B is a 3, times sine C. Sine theta value we got, that's a sine theta, please. 5 root 29 divided by 27. And you all know what is happening now. 9 times 3, 27 cancelled. The answer is 5 root 29 divided by 2. 2-3 different ways to do, but this is one of the methods. So that's the area, exact area of the triangle. They wanted us to prove area of the triangle AOB is that. Okay. The next question is a variety one. Watch there. It says, find a vector, not the vector. Find a vector which is at right angles, right, to these two vectors. Listen very carefully. What happens in 3D is you can't find just one vector that's at right angles to the given two vectors. You have infinite number of vectors that make 90 degrees angle with those two. So our aim is to find one of them just, right? So there is no unique answer for this. There are infinite number of vectors, okay? So I'm looking at one vector because there are infinite number of them that is at right angles to these two. The methodology is this. Let's assume there is a vector called C. There is a vector C which is xi plus yj plus zk. Okay. So the question says this is a vector which is at right angles to that. So the dot product of A and C must be 0. So we simply say x, y, z, write as a column vector, because it's the first question, we'll go slow. That is a 6, 1 and 3. A dot C or C dot A, it's still same. So if you multiply those two, we are supposed to get 0. So 6x plus y plus 3z is equals to 0. Dot product must be 0 because the angle between them is 90. Who said that means the question only said that. All right, that's the first one. The same thing happens to the second one also, because B is also, the angle between C and B is also 90. So let's write the column vector, or here maybe. Then that's x, y, z. Let's write x, y and z. The B is a 5i and k. J component is missing. So it's actually 5, 0, 1. Nothing in front means 1, please. So we multiply these two vectors as well, which is called the dot product. And that should come down to 0. 5x plus 0, right, plus z is equals to 0. Now compare those two. We have two equations to solve. If we can solve them, we got x, y, z, which is the vector, right? So let's see how these simultaneous equations are done. I already said that there are infinite number of answers for that. So what we do, we take 6x plus y plus 3z equals to 0, copy the 5x and say plus z is equals to 0. You are allowed to choose any one number, say z or y or x as a number. So let z equals to 1, right? Let z equals to 1. So if z becomes a 1, so we assumed because there are infinite number of vectors as the answers, we just choose one answer as z equals 1. So the first equation now becomes 6x plus y equals to minus 3, right? 3 times 1. And the next one should be 5x. 5x plus 1 is equals to 0. So it's a minus 1, right? 5x minus 1. 5x is equal to minus 1. We can solve that now to actually find the x value. Okay, once we said 5x is minus 1, x equals to a minus a fifth. So z equals to 1 we know, x is a minus a fifth we know, we can find z. Y, right? So let's take the, let's find out y now. So that's going to be 6 over 5 with a minus plus y. Z is 1, so it's a plus 3 is equals to 0. You all know how to solve those fractions, right? Y is equals to minus 3 plus 6 over 5. 5 times 3, 15. That's a minus 9 divided by 5. So I got 3 values. Now I want you to watch very carefully. What is happening here is we got 3 values of x, and let's write them as a column vector there. 3 values of x, y, z. Z equals to 1 we know, so let's write 1 there. X equals to minus a fifth, so let's write minus a fifth. Y value is minus 9 over 5, minus 9 over 5. To make it good looking, what you can do, take minus a fifth common as a scalar, right? So that should be a 1 now, watch, minus a fifth times 1. And that should have been a 9, and the last one should have been a minus 5. Okay, so that's the vector which is making 90 degrees angle with both of those vectors. So that's how you find that vector. Now you need to write that in vector form, if you ijk form. So C is equals to 1i plus 9j minus 5k, and then you leave a fifth, right? So not necessary, but that's how you actually find the answer. So it is important to know that there are infinite number of vectors that are at right angles. I will give you one more question. You try that, right? Find a vector that's making 90 degrees angle with those two. You can choose the third vector as you like. Let's say third vector is a D maybe, right? D is equals to, call it xi plus yj and plus zk. This time we don't need to write them in column vectors, we know. So a dot d should be 0, right? 2x plus 3y plus 8z is equals to 0. Then we also know that b dot d should be 0, right? Because the angle between them is 90. 3x and plus, watch there, that's a 1y, okay, 1y, and minus 2z. Minus 2z is equals to 0. You are welcome to choose x as 1 or y as 1 or z as 1. It's up to you. Let's just take z as 1, see what happens. We have simultaneous equations there. So I'm taking z as 1, please. So we have 2x plus 3y is equals to minus 8. Take that to the right hand side. And the second one becomes now 3x plus y is equal to minus 2 becomes a plus 2 there. And now you know how to solve these simultaneous equations, isn't it? We just need to multiply that by 3 maybe. So 3, that becomes a 6, that becomes a 9. Minus minus, and that's going to be a minus. Those two cancel out. That's a 7. Minus 7x is equals to minus 14, and x equals to 2. A good looking number, not ugly fraction. So z equals to 1, x equals to 2, you can find y now. And to get the value of y, let's just do it here. Let's take the top one. 2x plus 3y equals to minus 8. X value is 2, so 3y equals to minus 8 minus 4, and y equals to minus 12 divided by 3, which is a minus 4. What a lovely answer. We got all whole numbers. So the vector is, the D vector is xi plus yj plus zk. So this is 2i and y was minus 4. So minus 4j and z is 1, which we chose. So it's a plus k. So that's one answer. If your friend, somebody else, suppose chose x equals to 1, you get a different vector. But mind you, that also is making 90 degrees angle with the given two vectors. Okay, so the question in the examination sometimes how they ask means find a vector that is, that's the keyword they use, perpendicular to A and B, the A and B on top there. Okay, so the concept is very important. Take that as x, y, z, and simply find B, say A dot D and B dot D. You have two simultaneous equations in three unknowns to solve them. But because there are infinite number of vectors, we are allowed to choose any one of the variables as any number. It's better to choose one. Don't go and choose 249, please. That's done. So far we talked about the angle between two vectors, right? And we know when it is 90, when the two lines do not intersect, etc. Some of the basics also we have learned. Now it's part 2 in which we are going to see equation of a straight line in vector form and solve problems based on that. Okay, right. The next part, very important one, this is right, part 2 of vectors. Our aim is to find the equation of a straight line, sorry, that ST means straight line, that's passing through a point, and we need to find a general form for the equation of a straight line. In normal C1, C2, we know that's y equals to mx plus c, right? In the same way, we can find this as well. That's the center point of the graph paper, which is 0, 0, right? And there is a point A. The line is passing through A. Our aim is to find the equation of that red line, right? It's a vector, please say. Arrow is that side, suppose, but we are calling it as just a line passing through a point A. What I want to do is, I just want to draw a position vector there first from O. So that's a position vector, OA, called small a. I have taken another general point. This R is called a general point. R can move anywhere, right, on this line as it feels. So now let's draw a position vector line for R as well. Okay, so that's the position vector of R. So that's a small r. These two I have done. The other thing we need to know is the direction vector of this line, say AR, okay? So I'm going to draw a direction vector somewhere there, watch, so that's parallel to this line. Direction vectors, please, so that must be non-intersecting to this. So now what I have is, let's call this vector as a small b. So what is b? It's the direction vector. means it is telling us that this line is traveling in that direction. Okay, that's all. Because AR, now forget about the rest of the line there, concentrate on AR only. AR is parallel to B. That's a fact, right? So what we do, we go and say, okay, because it's parallel to B, that should be a multiple, only that much should be a multiple of B. So let's write that as lambda B. Lambda times B means it's twice that or thrice or four times or half, doesn't matter, it's just lambda, a scalar. So we all know AR equals to lambda B, right? We can use the triangle and find AR value also. If you need AR, from A, we go backwards to O and then reach R. So it's actually minus A plus R, right? So I can say R minus A. Watch, minus A plus R is also called AR. AR vector, right? So we have two types of answers for AR, isn't it? That's also called AR. This is also called AR. All that we do now is we equate them. We say, there we go, R minus A is equals to lambda B. That's what we will write. And below that, we make R subject and say minus A becomes a plus lambda B. This is the most important equation, right? This is called vector equation of a straight line, which looks like y equals to mx plus c, right? But just be careful. This A is the position vector PV. That B is the direction vector dV. Listen, they are my short forms, right? They are not in the textbook. So it's R equals to position vector plus some kind of a scalar multiplied by direction vector. So that's the equation of a straight line. Now I will spend more time on this. It's important that you know what is exactly happening. Remember, when I started this, I said A is a fixed point, R is a general point. So R can move anywhere, right? So if lambda is, suppose say 2, lambda is 2 means this is twice that line, twice. If lambda is 2, I get the coordinates of that point R. Suppose lambda moves, right? Lambda moves somewhere there. Sorry, R. R moves from that point to here. So this is called R1 now. Do you agree that this is still parallel to that, but the multiple is changed? Previously it was twice or thrice, but now it's less than that, right? So what we are saying is, as R moves on this line on its own accord, say, the lambda value gradually changes. It will increase if it moves on that side. If it goes there, it will decrease. The most important thing now, what happens if R lands on A? R moves slowly, so lambda value goes down, comes there, then it's 0. Lambda becomes 0. If it goes on that side, maybe it becomes a minus, right? So it is important to know the meaning of R and A and B. So I will write it again for you. R equals to A plus lambda B. Please understand, R is any point, a general point. It's the position vector of the general point. So we can call it x, y, z, nothing wrong. Is equals to A is A plus lambda B. If we know A and B, then we can easily find, also if we know that, we can find x, y, z. As lambda changes from 1 to 2 to 3 to 4, the coordinates of those points also change as they move. So that is R1, R2, R3, R4, it goes like that. Very important, please remember, R equals to A plus lambda B. Right, that's the vector equation of a straight line. I will take you through one question to actually see what it means. Like, okay, let's take our own sum. I didn't prepare one, so I'll just copy a question there. So we have a position vector, right, called A, which is 2i plus 3j minus 5k. That's the position vector, please, of a point A, which is OA. Then I have the direction vector given to me as, for example, I plus 2j minus 4k. They want us to find the equation of a line passing through A, which is parallel to this. So I have a straight line, right? It's passing through a point called A, and the coordinates are 2, 3, minus 5. Watch, 2, 3, minus 5. This is parallel to another vector called I plus 2j minus 4k, right? So this is like B now. It's parallel to that, so that length should be lambda B. So what we do, we say R equals to A plus lambda B. Watch very carefully. A is the position vector. So we copy the position vector, which is going to be as a column, suppose 2, 3, minus 5, 2, 3, minus 5, plus I will write lambda as lambda, and B is the direction vector 1, 2, minus 4. I'm just taking those numbers, please. So it's a 1, 2, minus 4. Now, this is called the equation of a straight line, or that line in the vector form. We know R equals to x, y, z. So let's go close. It is important to know this very, very well. What is R? What is A? What is B? What's lambda? Suppose lambda is 0. X equals to 2, y equals to 3, z equals to minus 5. Remember, we said if R moves and falls on A, lambda becomes 0. Then the position vector itself is R. That's point number 1. If lambda is 1, for example, x coordinate will be 2 plus 1 times 1, which is a 3. So x coordinate 3. Y coordinate 3 plus 2, 5. Z coordinate minus 5 plus minus 4, minus 9. So there is a point called 3, 5, minus 9 on that line when lambda is 1. So R is that point like. What happens if lambda becomes a 2 means now the point changes. So it's 2 plus 2 times 1, that's a 4, and 3 plus 4, 7, and then we have minus 5 and minus 8, minus 13. So what happened? We said it's twice that direction vector. So as lambda changes, we get all the points on that line, right? All the infinite points as we have infinite number of values for lambda. So that's the concept of R equals to A plus lambda B. The first one is the position vector. The second one there, the one which is next to this scalar, is the direction vector. Very, very, very important. It might, I mean, you might think it looks like y equals to mx plus c. That's the gradient, isn't it? So here that lambda is a kind of a gradient. So, but I don't like to call it as y equals to mx plus c. I want to take the same question and see there are 3 types of equations of the straight lines that we can make, and I will explain that first. Then only we move to the next part. Equations of straight lines, very important, please. So I'm preparing a small question there. We have position vector is given to me as 2i plus 3j minus 5k. Direction vector is given to me as 3i minus 4j plus say 3k. Done. They want us to write the equation of a straight line passing through the point A, which has a position vector A and is parallel to this. Guys, direction vector means that straight line is parallel to this line. That's what it means, right? So I would like to say the R equals to position vector plus lambda times direction vector. So A plus lambda B. So let's go and say A is 2i plus 3j minus 5k, close the bracket. Very, very important one. So listen carefully, please. Lambda times 3i minus 4j plus 3k. Off the screen? Yes. So guys, now listen. This is called vector equation of a straight line. This is how you write, or you can use column vectors.